All right, this is 4.7 inverse trig functions. The first problem wants us to find the domain of the inverse sine function. Now, the inverse sine function, we went over this in the notes. If you graph the regular sine function, now I know the sine function keeps going, you know, it's a sine. But if we just graph from negative 90 to 90, because that's the part that we're going to reflect. If we reflect it over the line y equals 1, you basically get the same function again, only it's, I guess it's a little bit different shape. But nonetheless, you know, we're not going to keep going with this, because if we did keep going, this thing would, you know, would be a sine function that it wouldn't pass the vertical line test. So that's why we have to throw out, you know, the repetition part so that we can actually keep this a function. So it's only relevant for us to look at the domain being from negative 1 to 1. And the range is then from negative pi over 2 to pi over 2. So keep in mind that we just flip the domain range of the original sine function. So the original sine would go from, you know, negative pi over 2 to pi over 2, so that we can make that the range. And, you know, the range of the original function would be negative 1 to 1, so we make that the domain. Okay, the next problem, complete these equations. The inverse cosine and cosine, these basically undo one another. They're inverses of each other, but be careful with this one, because if you graph this on a unit circle, negative 25 is down here, right? Negative 25 degrees. And the cosine relationship for this would be adjacent over hypotenuse, which is positive. So this is actually a positive value. You do your calculator. And then the inverse cosine of that positive value gives you back positive 25, not negative 25. So when these don't simply undo one another, you do have to pay attention to signs. When it's negative, be careful, because oftentimes this will end up being positive. Okay, the next problem wants us to match these with the ones below. I know these are kind of small, I can make them bigger, but I would get rid of cosine and sine first, because those are the ones we're really familiar with. Cosine starts off at its largest value, and then is the sine, you know, a sinusoid wave from there. And you can double check, this is pi right here, where at pi, cosine is negative 1 at its lowest value, so that's E. And sine is A. Starts off at 0, and then at pi, 3.14 right there, hard to see unless you make it bigger. It's back to 0, and then it goes lower. So that works. Tangent, we know what that looks like. That's C. So the inverse of sine is B. We know what that looks like too. And if you're not sure, you know you have now B left, and you have D, and you have F. D is an easy one because it's the reciprocal of tangent. You can see how this goes on forever that way, and so does that way, which basically flips the domain and range of tangent, so that the domain of inverse tangent is all real numbers. And you can get that formula sheet as well. The domain is negative infinity to infinity. And you can see if that's the case here in this graph, so that one's pretty easy to get D from the inverse tangent. So now all you're left with is how to choose between inverse sine and inverse cosine. And like I said, the formula sheet's a good place to look. You'll notice that the cosine, the range goes from 0 to pi. And so you have just a positive values for your range, which is exactly what this function has, so that's F, which makes 4B. Okay, the next problem says find the exact value for each of these. So the first one is inverse sine of square root of 2 over 2. So let's look at that in unit circle. That really means the sine of some angle equals the square root of 2 over 2. So where is that at? Well, that's right here on our unit circle, 45 degrees. And just double check that works within, because understand what you're getting out of this 45 degrees. That's the range. So just make sure that fits with the range in the formula sheet. The range is from negative 90 to 90. So 45 fits fine with that output, so that's fine. And then cosine, same thing. It's 45 degrees again. That's the same spot in the unit circle. So it's the same exact thing where we know the angle we're talking about is 45 degrees. It's just a matter of checking to make sure that works with the range for the inverse cosine, which it does. And then the next one is the inverse cosine of negative square root of 2 over 2. So that's a different spot. That means that the cosine of some angle equals negative square root of 2 over 2. So we're talking about going back here, and we're either at this point or this point, right? Because that's where the cosine of that angle, both of those equal the negative square root of 2 over 2, the x value. So the question is, which one is it? Well, we can look at the formula sheet and just find out that the inverse cosine, the range is from 0 to pi. So we have to be talking about values that come out in this interval only. So we have to be talking about that one, which is 135. And then the sine of this would be the same thing, only now we're talking about sine. So negative square root of 2 over 2, we're talking about a y value then. So we're talking about down here. If you look at your unit circle, that's a negative 45 degrees, and that does work for the domain of the sine as well, so it'd be negative 45. All right, the next problem gives us this cosine function that's been shifted and stretched, and it wants us to find the inverse. To find inverses, we switch x and y, so I'm going to call this x now, and I'm going to call this y. And I'm going to solve for y, so I'm going to subtract 3 from both sides, and then I'm going to divide by 7. And then I'm going to take the inverse cosine of both sides. Solve inverse cosine of x minus 3 over 7 equals 7y. Inverse is undo the original function. And then I'll divide both sides by 7. So that's my inverse. Now keep in mind they want you to enter in arc cosine. So make sure you close those parentheses or put parentheses around the whole thing then. And that should work for the inverse, which I'll call inverse function of x instead of y now. And then the domain is tricky. The domain, you have to look at the range of the original function. Now keep in mind this original function has been shifted up 3 units, and then it's got the amplitude change of 7, so it goes down to negative 4, and then up to positive 4. So, up 4 from this, or I'm sorry, up 7 from this line right here, which would take you all the way up to 10. So, you know, this cosine function is fluctuating between negative 4 and 10. So I need to make sure that becomes my domain because we have to switch the domain and range for inverses. So take the range of the original function, you get the domain of the new one. Okay, the next problem says the angle is between 0 and 90. The sine of this angle is given here, so just do inverse sine. You can do this right in your calculator. And just make sure that what you get out, keep in mind, has to fit within the range that our formula sheet gives for, it has to be between negative 90 and 90, which it will be. So these you can do right in your calculator. Just, you know, double check that that you fall in the right range. And if you don't, ask me and I'll go over that in class, and we'll figure out what that means for your problem. Next problem is pretty easy. You know, the sine of an angle equals a ratio or a value. So K represents the angle in this case, C represents the value, but when you do inverse, you switch them. So now this is the angle D, and V is the value of the trig function or the ratio. And arc cosine is just it's the same. So the angle's on the other side here, and the ratio or the value is A. Okay, this next question is a little easy too. Make sure your calculator mode is in degrees, and you can just go ahead and do this. Tangent of 28 in your calculator. For me, that gave me 0.531. I think I used 0.532. Then in the calculator, inverse tangent or arc tangent of 28 gave me 87.95. And this means the same thing as arc tangent, so that's the same exact answer. This is different though. This is the tangent of theta, which is 0.532, and then inverse of that, which is actually the reciprocal of this 1 over 0.532. So when it's outside the parentheses, it doesn't mean inverse tangent. It means evaluate the tangent and then reciprocate it. Same thing for this one. You can do it right in your calculator. So the sine of what angle gives you this value. Just do inverse sine of this. Type it all in. And, you know, for me, I get 25.3 here. Just double check that falls within your range, acceptable range for sine, and it does. Go ahead and you can just do the same thing here. The last one's, I guess, a little tricky. Because secant is really 1 over cosine. So you really have 1 over cosine. And I'm going to do inverse secant of this 1.10609, which is really, actually, better yet, what we can do is, from the original equation, we can make it 1 over cosine of theta equals this 1.10609. And if we then cross multiply, we get 1 over this 1.10609 equals our cosine, and then do inverse cosine. So we want inverse cosine of this fraction right here. And that will work to give you 25.3 about, and that works fine. The next problem gives us this function here. I'm going to actually switch x and y, and I'm going to find the original function because I find it easier to find the domain and range of the original and then switch those. So I'm going to take the sine of both sides, and then subtract 1, and divide by 3 to get y. So here's my inverse function then. Or here's my original function rather, because I went backwards. So I'm going to look at this, I'm going to rewrite it as 1/3 sine of x minus 1/3, so that I can take a look at the graph, because that's the easiest way for me to visualize the domain and range. The domain is all real numbers, I can stick whatever I want in. The range though, this thing's been shifted down 1/3, so if this is 1, there's 1/3, there's 2/3. So it's been shifted down here, and it fluctuates in between 0 then and negative 2/3. So my domain is negative infinity to infinity, and my range is negative 2/3 to 0. Now I'm going to flip these for my answer, and keep in mind that my range for my answer can't be negative infinity to infinity. Let's use negative 2 pi to 2 pi for that, because we have to restrict that. Otherwise, when we go to flip this thing, the range can't be all real numbers. It's got to be just negative 90 to 90, so that we don't get we only get one period in there, so we don't violate the definition of a function. So flip these, but make this negative pi over 2 to pi over 2. That works for me. If I flip them, anyways. Okay, the next problem, it wants me to find exact values. So I'm not going to pull out my calculator because that won't help me here. I'm going to instead graph. This means that I want the secant of the this angle in here, first of all. That angle in there is really the tangent of some angle equals 2. So I don't know where that angle is, but I know the tangent is 2. So I'm just going to draw a reference triangle in here and say that this is theta, and the tangent then is opposite over adjacent. So that'd be like 2 over 1, in which case this would be the square root of 5. So let's use that as a reference triangle. This works. This is where the sine and the cosine are both positive, so the tangent would be positive. If I want to do the secant of that, that's the reciprocal of cosines, that'd be hypotenuse over adjacent, so it'd be square root of 5 over 1, or square root of 5. And the next one then, if you draw another reference triangle, you're talking about the sine of some angle in here, just isolating this part, equals 5 over 13. So if you draw a reference triangle here, for example, sine is opposite over hypotenuse, which would make this 12 if you do the Pythagorean theorem. So there's our reference triangle, but we want the cosine of, so here's our angle, but we want cosine of 2 times that angle, right? So that's a little tricky. In fact, I don't think we can do that one yet because we haven't learned these double angle identities. But you can use any one of these double angle identities to help you do the exact value. So if I did cosine squared of u minus sine squared of u, I could then find cosine squared of u minus sine squared of u. So that'd be the cosine of u would be adjacent over hypotenuse. So that'd be 12 over 13. Got to square that. Minus sine is opposite over hypotenuse. It'd be 5 over 13 squared. And this would be 144 over 169. This would be 25 over 169. And there's your answer. You could simplify that a little bit. 119 over 169. That will work. Now, technically we haven't learned this double identity. That's not coming up for a few sections, or until next chapter. So if you don't want to do that part, that's fine. That's not the end of the world. We'll get to that. Okay, the last problem is just a little review. Pull up your formula sheet, and I got all the information right there for the domain and range of inverse sine, inverse cosine, and inverse tangent. So it shouldn't be hard to fill that out.